Okay, so 2.4, specific heat capacity. What we're looking at here is we're looking about how when you add energy to a substance, you change its temperature. And how much the temperature changed by depends on two things, and those two things are how much mass it has and how hard it is to heat up, which is known as the specific heat capacity, and it's a small c. So if you put in energy and you've got a larger mass, the temperature change isn't going to go up by as much. If you increase the amount of energy though for the same amount of mass, the temperature is going to go up by more. If you try and heat a substance that's harder to heat up, but higher specific heat capacity, then the temperature isn't going to go up by as much either. And we can put that into the triangle here. And delta just means change. So this triangle just means change. So change in temperature. And if we want to know what the units for specific heat capacity are, we know that energy is in joules, we know that mass is in kilograms, we know that change in temperature is in delta. That's Celsius, which is this bit here. So that means that the units for C are going to be joules per kilogram Celsius. And then if we were doing this as an experiment and we wanted to work out what the specific heat capacity of a substance was, we need this electrical circuit here. We need an ammeter to measure the current, we need a voltmeter to measure the voltage, and we need a power source. And the reason why we use this system here is because we can very accurately work out how much energy we've given this heater. Okay, far more so than we can work out how much chemical energy we've given a Bunsen burner, because we don't know what the flow rate of the gas is, or how much of the gas was burnt, or at what temperature it was burnt. There's too many variables, whereas with the electric one we can sort it out with just current and voltage. So power equals current times voltage, and power equals energy divided by time, which means that energy divided by time equals current times voltage, which means that energy equals current times voltage times time. And the only one of those three that you should be changing is the amount of time. So what you then want to do is you then want to put your heater either into a liquid, so long as it was electrically safe to do so, so you don't want any bare contact touching, you want it to be waterproof, to stop any bare contacts from touching the water, or you want to put it inside a block of the substance that you are trying to investigate. They're the two ways. So long as it is completely immersed within either the substance or the block, then you're fine. So either in a liquid or in a block of the solid. Both methods would work. Okay, and then what you're going to be doing is you're going to be recording how long, so time, and you're going to be recording what the temperature is. So, and I don't know, every 30 seconds maybe. It would depend on how much of the substance you've got and how much energy you're putting into, whether that's sensible. And maybe it starts at 20, roughly room temperature, and then goes up, and you then will plot a graph of temperature against time, and you'll be able to see how that temperature is increasing. Okay. Now, if you your control variables, things that you really need to control are, you need to make sure that it's the same amount of mass. You need to make sure that the circuit stays the same temperature. Okay, so I'm not talking about the block being the same temperature, I'm talking about the circuit being the same temperature. So just because you've got a heater here doesn't mean that you should let anything else warm up, because as the heater heats up, and the circuit heats up, the resistance would change, which would change the voltage and the current. You want to keep the voltage and current the same, because that's the rate at which you're providing energy. Okay, they're the things that you want to keep the same. and from this we can work out what the specific heat capacity is. And if you know what the specific heat capacity is, then you can determine different uses. So some things you want to have a high specific heat capacity, some things you want to have a low specific heat capacity. So for example, something called a storage heater, which they love asking you questions about in an exam. And a storage heater has basically got concrete blocks around the heater, and these concrete blocks have got a very high specific heat capacity, and what they're used for is overnight they store up energy. The temperature change, so the high specific heat capacity, which means that delta temperature is low for a given amount of energy, but it means that they've got that energy in them for a long period of time. So you put in a lot of energy and it's released throughout the day. So that's a storage heater. As an example of something that uses a high specific heat capacity, you get a lower change in temperature, but it means that you're giving off energy for a longer amount of time.